Stewart Warner combustion heater AD, and I'd just like to bring the forefront the reasons why this AD was produced. There was an NTSB safety report that was sent out dealing with a Beach 18 that was en route to Grand Rapids, Michigan. And the pilot reported an engine fire. He was in contact with the approach control. He then, about 10 miles out from the airport, he transmitted that the flaps are on fire, followed by the whole engine is on fire. The aircraft crashed about 6 miles short of the airport and burned. The pilot and 3 non-revenue passengers were fatally injured. The aircraft's left heater, which the heaters were mounted in the wheel wells on this airplane, the left heater combustion air blower located in that location separated at impact. They found in the wreckage the combustion heater itself also. The stainless steel heater shroud was dark blue in several areas, which is indicative of exposure to extreme temperatures above 2,000 degrees. The heater was disassembled, found that the combustion air orifice was about halfway open. There was soot in the combustion air chamber behind the fuel nozzle. The fuel valve seat was cracked in a couple places. The igniter was corroded. The gasket between the burner assembly and the heat exchanger was burned through and showed evidence of leakage. So thus, from that NTSB report, they developed another AD, but this AD was applied to the Stewart Warner airplanes, AD 810909. This AD calls out for, and we'll just look at the perimeters of the AD, what they expect you to do. Basically, they're asking for the combustion heater, any heater that has over 250 hours in service, to have an inspection in accordance with the service manual. The 250-hour inspection procedure given in the manual just consists of a visual inspection. That's why the AD is a very limited AD, and it's, in our opinion, and we've been saying this for years and years, it is a dangerous AD. The other portion, they say every 250 hours then they have to do a visual inspection. Well, the visual inspection just includes looking at the drain to make sure that the drain is clear, looking to see if there's any fuel leakage of the heater when it runs, making sure that all of the openings are clear as far as the ventilating and combustion air openings. And that's the extent of it. If it run on the ground and those things were okay, they did their portion of the 250-hour inspection. On accumulation of 1,000 hours on this heater, then they have a mandatory overhaul period. Now this is where this AD really becomes a serious issue and a problem, because it's from our experience that a combustion chamber, the burner chamber inside the heater, which is the main component for safety, if that chamber is left in a heater, it'll deteriorate on its own, even if the heater isn't operated hardly at all. It'll deteriorate within about 1,200 hours. According to the AD, if you overhaul it according to the maintenance manuals of Stewart Warner, if the combustion tube checks good when they overhaul it at 1,000 hours, they're allowed to say, okay, the chamber checks good, pressure decay test is good, there's no leakage. They're going to put it back in that heater and they're going to run it. And according to the AD, the next time they have to look at it is another 1,000 hours. So at that point, the combustion chamber, that heater, is going to end up with 2,000 hours on it. It's a proven fact from our experience of overhauling these heaters for years and years. The combustion tubes will never last 2,000 hours. Very doubtful will a combustion tube last over 1,200 hours. It's fortunate if a combustion tube makes it to the 1,000 hours. So if they do it according to this AD and according to the overhaul manuals that Stewart Warner produced, they will overhaul it at 1,000 hours. If the combustion tube checks good, they'll stick it back in the heater, they'll return it to service, and they don't have to look at it again for another 1,000 hours. That combustion tube will operate in excess of 800 hours with a crack in it or a hole in the end dome. So that's the reason why this AD is a bad AD.
I am Bill Sandman with C&D Associates, and today we're going to be discussing the Southwind combustion heater. We're going to show you some functional testing of the unit on a test bench. We're also going to talk about some of the common failures that we find with the Southwind heater. On the bench right now is an 8259 JR2. This is a pretty common Cessna heater, pulled directly out of the aircraft. We have no time on the heater, but we're assuming from the burn characteristics of the combustion tube and the look of the metal that it's got about 300 hours on it. And this heater with 300 hours on it was pulled out of the aircraft with a failed combustion chamber already. So time since zero time overhaul was only 300 hours. That tells you how quick some of these fail. We've actually removed the end dome from that heater. We're going to show you what the flame looks like coming out of the back end of it, and what an extreme example of catastrophic failure could look like if not maintained properly. The customer opted to put in a C&D replacement, PMA replacement for the 8259. They put in a CD 14073 combustion heater -1 series. We do have AMOC to overhaul these units, the Southwind units, to relieve the AD 810909. C&D replaces the combustion chamber with a redesigned combustion chamber that will make TVO and more. We also change various components on the heater, not only to make it last longer, but to be more efficient. And some of those changes are proprietary, but they do increase the life of the heater. So here we have a basic combustion tube for the Southwind heater, probably an 8259 that this came out of, that we've cross-sectioned. And in here you can kind of see what the burn does. Stainless steel is a great metal actually for combustion tubes. They will last if they're treated properly and the fuel pressure is proper and everything is working properly. They can make TVO no problem. And this one shows the cross-section of the actual crossover for the combustion tube. So air comes in here, here's the spark plug, air comes in, shoots straight down, hits the spark, the fuel hits the spark here, the fuel is atomized, so it creates the burn. Most of the burn happens down in this portion. You see a lot of carbon buildup in here. It's because you really don't have a burn up here in the mixer area. The burn is happening down in the burn chamber. And the way the Southwind is designed is it has a full-length crossover that runs the full length of the main portion of the burn chamber. The problem with this design, as we have found, is metal obviously expands and contracts at different rates. So if you have bends in your metal, you have different, you have folds in the metal, you have a lot of things going on, you have different levels of welding. There's a lot more welding on this. The problem with this combustion tube, mainly, and why they fail so quick many times, is because they're not expanding and contracting at the same rate. This end here, this whole side of it, the combustion heater, does not expand and contract as fast as this side does because of the buildup of metal. Does that make sense?
Zoom in here, you can see a good example of this crack here. It runs at least an inch across there, and then again on the other side it starts here and runs all the way out to here. And that is a failure. Will fail pressure decay test. This one actually has a major failure here on this crack. As you can see, it comes across, starts here and comes all the way across. And then this one is actually separated here and it comes all the way across here. So this is definitely a failure.
Now what we're going to do is we're going to run the unit. We're going to see what the unit looks like without the flame tube on the back of it. And the reason why we're going to show you that is because when we do IA renewals and when we do safety seminars and combustion heaters, which we do a lot, we describe the combustion heater, why we take it so seriously is because it is actually a flamethrower with a cap on the end of it. That's how we view the combustion heater. And that might be extreme to some people, but that's why we have the record of safety that we do.
Today we're using our custom-made test stand we use to test all our heaters. We're going to be supplying the heater with 24 volts DC and 25 psi of aviation 100 LL fuel and simulating a failure of the endo. So go ahead.
This is basically how the heater would sit in the aircraft with the exhaust down in this situation. If there was any leak in the crossover of the combustion tube at this point, and the fuel continued to drain into there, the fuel is able to drain out and into the ducting. And that's where the real concern is. Now, on these Southwind heaters, the 99% of the time where the failure actually is that it would not pass pressure decay test is up here by the crossover portion of the combustion tube. And we'll look at some of those failures. But the real concern here on the Southwinds is if for some odd reason you don't have a good spray pattern, if fuel is able to pool inside of this combustion tube, this inner liner, it's able to build up a little bit of fuel, it starts to leak out a crack, and it's able to get into ducting. That is, the ducting is really a big part of the problem because the ducting does not resist heat now that it's 50 years old or so. This combustion air switch. This is made that if there's not enough airflow to burn, to get a good burn, a clean burn, this switch is supposed to actuate and shut off all components that would allow for burn, including fuel and ignition. These switches also are getting old. They're just past their prime. There's no time date on these heaters, so nobody, unless it's overhauled by a repair station that knows what they're doing, nobody many times knows to look at these switches very well. And instead of clicking up at a third of their throw, many times they'll click open or they'll hold open. And again, that safety feature is also no longer effective. To sum up AD 810909, dealing with the Southwind Stewart Warner combustion heaters, C&D Associates here in Buchanan, Michigan, we spent a lot of time developing replacement parts for them. So we feel the main areas of concern in the first place regarding that AD, and as Dennis had mentioned before, the reason why we consider this a bad AD, and we always have, is really a two-part concern. The first part concern is the fact that the time limit on these combustion tubes is set at 1,000 hours, and the 1,000 hours calls for inspection of the combustion tube. It doesn't even necessarily specify pressure decay test unless you look in the manuals for the 8472 series. They all need to be pressure decay tested, and they all should be pressure decay tested more frequently than every 1,000 hours, especially for this design. Due to the design characteristics of the original Southwind combustion tubes, the time limit, as far as hour limit, time in service, is way over what we would consider safe. The second area of concern is the fact that there is no calendar limit as to when these systems should be serviced or inspected. So we tell our customers is basically to follow the Janitrol AD, which calls out for a 100-hour pressure decay test or 24-month calendar time. That these combustion tubes mainly are inspected thoroughly. Inspection is not visual inspection. Inspection involves a pressure decay test. Most of the time that means that the heater needs to be pulled out of the aircraft, but for the sake of aviation safety, which is our chief concern, we can't see any other way around dealing with this. So that's our take on the 810909 AD.